Hello everyone, in today's tutorial I'll be going over how I made this cookie pool effect using some volume VOP tricks to build the cookie, the new NPM solver for the inner chocolate, and some information about texturing with Copernicus in LOPNET. We'll go through the modeling of the cookies, creating the pooling effect, and a highlight of some information with Copernicus. So let's get into it. Okay, so to start our cookie, we're going to use a sphere. We're going to clip that, and then we're going to create a VDB from polygons, which we're going to use to add some noise to the sphere and make it look more like a cookie. So I've dropped down a geometry container, and now I just want to put a sphere inside. I'll change this to 0.35, and that's everything for here. Next, I'll add a clip node, and I want to clip it on the y-axis and not on the x, so it looks like that. Next, I'll drop a polyfill node, and I want it to be a quadrilateral fan, so it looks like that. Next thing, I'll add a null here, and I can call that my initial cookie. Then I'll create a poly bevel because these edges are really sharp, and I will select these edges, and I want this distance to be something like 0.035, and I want to increase the divisions to 3. It looks fine. And then I want to add a subdivide node for more resolution for the VDBs and change that to a depth of about 2. So that's what we have. Next, we can make a VDB from polygons. Set the voxel size to something like 0.04. Increase the exterior band voxels. Add fill interior and change this to density. This is a similar process to how I made the marshmallow tutorial. Next, we can make a volume VOP. And in here, let's start off with the turbulent noise. P. And we always want to add that with what we initially have. Okay, awesome. Let's change this amplitude to -0.03 because we want it to bulge out. And let's change this frequency to maybe 30 across the board. That actually looks like a nice shape for a croissant. Maybe we can do something about that another time. Okay, so let's set this to 30 and this also to 30. So it looks like that. Very interesting. We can increase this roughness a bit and maybe take up this turbulence somewhere like there. Okay, so that looks like a sort of cookie, and what we want is we only want this deformity or this detail at the top of the cookie and not at the bottom. So we can do a relative to bounding box and ask it to consider the bounding box of the object based on a particular axis and scale that noise along that axis. So we'll use the OP input 1, which is the first input, which is our geometry, and do a relative to bounding box. And then we want to convert this to from vector to float, so we can have access to the 3 different axes. And we want the y-axis, which we are going to put in a ramp parameter. We can change this to a spline ramp, and we can call this height 1. And we're going to do a multiplication between the turbulent noise and the height ramp. Okay. And put that into the add instead. Alright. And just by doing that, we can see that it's scaling that noise across the Y. So at the bottom, it's not as noisy as it once was. This was it before, and this is it after. Okay, and we can redecorate how we want the map to be. So we could affect the ramp right here and say maybe we want another point here, another point here. So let's take this one down. Feel like, yep, I've created another point. My mistake. Yeah. So let's say we take this one down, and then this one is up. Move it a bit closer. So you can see now that the bottom is flatter, and this is where the noise is showing up. We can just move that to smooth it out a bit and maybe raise it a bit higher, so it looks more like a gradual progression. So now we have the noise concentrated at the top. So we aren't done just yet. We can dive back into our volume up, and something I really liked from the references I saw was that the top looked like it had some cracks. Maybe when they're making it in the oven, as it rises, it cracks and opens up. So we could accomplish that by using the unified noise. Static. Just close most of that and leave the other. And I want to put the P into the position. I can do an add between the two. So let's say I'm putting this into this instead. Well, that's disappeared. And then let's change some of the noise to maybe this. And let's change the frequency to like a 10, 20, 10, 10. And the fractal type we want is standard. We can affect the lacunarity, change that to 1.6, and the roughness to 0.53. And we want to change the output correction to complement, and the final amplitude to 0.1, 0.1, and 0.1. Okay, so this is kind of what we have right now. And we can control this noise more by making a fit range. This is something that I saw from another creator, Rohan Davi, who makes amazing Houdini tutorials. And so for this fit range, we can change the source minimum to affect how the noise is going to look. So see, already it's giving us some nice cracks. We can also change the source max as well. Makes the cracks look like that. And then for the destination max, maybe set it to something like this. So that's how the cracks look like right now. Very interesting. And we can also multiply this by a height our height, so we can, I don't know why that keeps on ticking, so you can copy this, paste it, and now I want this one to be called height 2, and I want to multiply it with this one as well. And the multiply can then go into the add. And now for height 2, we can make something similar. So let's put point here, take that down. And push this here. Okay. Now we have a lot of cracks at the top. And we can get more creative with this by adding other unified noise with a similar setup. One thing we can do is to distort the edges of the unified noise, and we can do that by adding a turbulent noise. We want to add that with our original position. And then plug this into the position of this one. Okay. So let's say for this turbulent noise, we want to set it to have a little less amplitude, little more roughness, like that, so it looks more wavy, less uniform. And we can change all of this frequency, maybe add some more variation to something like that. Okay. Now let's do the same for another unified noise. So let's just duplicate this setup. And we want to do an add between these two. So let this be 1, and let this be 2. And for this unified noise, let me see if I need to change anything. I think I did change something by decreasing the frequency of this so I could have larger swells in my noise. So let's plug it so we can see what we're doing. And so this add is the new add here. All right, yep. So we can change this again. And it will give us some different types of cracks and breakups. All right. And for this one, maybe I can reduce the roughness, and I believe I'll lift the final amplitude as the same. So we are adding two different unified noises. We are adding some turbulence to the edges of the unified noises, and we're making sure that there's a reduced noise at the bottom of the cookie. So let's also add this with this other turbulent noise that we initially created. So this is the final add. So let's add one. And let's add this one. And let's add all of this to this. All right. So that's what we have right now. Okay, and we can change the last ramp. So just look that there. Because this is how it looks like at the bottom. And I just want to drag this down a bit. Takes a while to load. Okay. So everything I want is at the top. And next we can add a VDB reshape node. And then I can add a VDB smooth SDF. And that's a lot of smoothing. I don't want that. I want maybe one iteration. And then I can do a convert VDB. I want to convert that to polygons. So this is how our cookie will look like. So you can play with some of the shapes to give you a different looking cookie and give you some different results. I will include my actual cookie in the project file. And for this one, we can just call it our cookie base. So this is what we're going to do. The next step is to create a Boolean fracture, add some noise to the interior of the cookies, and also cut out the part where our chocolate is going to sit inside the cookie as well. Okay, so let's create the inner workings of the cookie. Let's put a geometry node. We can call this cookie. We go in, let's bring the object merge. And let's take the our cookie base. So we have our cookie. And let's create a grid that we're going to use to divide the cookie. If I just put that there. Okay. So I want this to be on the YZ plane. And let's add more rows and columns. And let's reduce this as well. Okay, this is what we have. And then we can add a mounting node. And for this one, maybe just reduce the amplitude by a bit. And can reduce the roughness. And that's about it. Okay. Next, let's add a Boolean node. This goes into geometry B, and this is geometry A. So if we set B as a surface, it should just slice through. And now it looks like it hasn't done anything, but we're going to check that. Let's just put the output groups, which we're going to use later, and maybe also these seams. Sometimes they're useful, sometimes they're not. And oh, for this we need it to shatter. Yeah. So if we look closely, we can see the line as it cuts across. And next, let's add a clean node. In the clean node, we can increase this. Okay, so that's messed up our geometry a bit, so let's just undo that. And let's drop an assemble node. And for this assemble node, what we need is for it to create packed primitives. And then we're going to put that into an exploded view. And now we can see how separated it is. Okay. Okay, so let's set it to a reasonable distance because we're still going to close that up eventually. So let's set this to maybe 0.058 and let's unpack it. So the reason we're doing this is when we convert it to VDB, we don't want everything to just merge back together after going through the trouble of doing a Boolean. So once we unpack it, then we can work with the geometry that is within the cracks. So let's take a group promote. And we want to use one of the groups that we have here, the B inside A. So for the group promote, let's pick that B inside A. And so it selects only those within the cookie. And we can change that or create an attribute from that group as well. And what we can just say is if I at group underscore B inside A is equal to 1, I at inside bias is equal to 1. So now we have inside bias and we have the group as well. And from this we can make a VDB from polygons. And we want 0.03. And we want that to be density as usual. And we want to fill the interior as well. And just like in my marshmallow tutorial, we need to make sure we still have that attribute. So let's bring in point inside bias and call it inside bias. Okay. And next we can drop a volume VOP. I'm not going to spend as much time developing this noise as the cookie. We just need a bit of disturbance at the edges. So within the volume VOP, let us add a turbulent noise. And for this turbulent noise, change the noise to 10 across 10. Let's reduce the amplitude and take the roughness like that. And we want to do an add node between this and the turbulence. Okay, so this is what we have. Looks pretty interesting. And we can add another turbulent noise as well. And for this turbulent noise, we'll take the frequency down to 5 by 5 by 5. Let's just take everything down actually, because we just want to mix it with the original position. So we don't actually need this turbulent noise. We just want to mix the position with the mix node. So let's drop a mix node and let's add a bind. And the bind is going to bring in the inside bias. And I want to change this to integer because it's not a float. You'd be able to tell if it's a float just by looking at it. This Z and the P is a float. This is an integer. So if you don't change it to integer, it's not going to work. And we want to set that to mix based on that inside bias. Okay. Right, yeah. So that's probably, yeah. So this is converting it to be, I can't remember what it's doing. I think it's converting it to be a float or something. And if I connect the P directly to the mix, then it messes it up. So that's why I use this turbulent noise. But I'm sure there's a more efficient way to do that. And this is the method I have for now. So what we have now is all of that nice noise just inside the cookie. And if we come back out, the next thing we can do is to make that hole where the chocolate is going to be. So what we can do is to bring in our initial cookie, our cookie, and we just want to transform it slightly. And the transform I found worked for what I wanted was if we scale this by 1.5, this by 0.8, and we move this 0.05. So that puts it at the center of the cookie. We can reduce this scale 0.66. So that puts it more at the center of the cookie. So when this pulls apart, it's going to reveal the actual cookie. Okay. And then we should subdivide it so we have more resolution. We want to subdivide this by 3. And then we can make a VDB from polygons. And so for this one, let's just make it slightly more detailed. And then we can do a VDB combine of these two. And right now there's no hole. So what we want to set that to, it should be SDF difference. So that's what's going to cut the hole in the VDB. And after that, we can add a VDB smooth. I prefer the VDB smooth SDF. And we want to reduce this to 1. Okay, so now we have our cookie. Let's convert that to VDB. Let's convert that to polygons rather. Okay. The next thing would be to separate the two because we want the cookie to pull apart. So how we can do that, let us add an assemble node. Let's create packed primitives again. And then let's just put a blast node so we can separate the two. All right. Okay. And if we do this, we'll say delete not selected. So now we have this nice cookie that has an interior. And let's merge the two of them. Move them together using a transform. Just needed to edit my near and far clip planes. Okay, so we bring both of them into the merge and we can move them and we can move it by 0.015 and we can move this one minus 0.023. Okay, so now it looks like the cookie is whole, but it's not. So let us just cache all of this on its own, and then we can work on the camera and work on the inner chocolate. So for this, let's unpack it again, and let's cache it. Before I do that, I should add Labs Auto UV. And the reason is because of how it's going to appear in LOPNET. So we need the UVs when everything is really big so we can have more detail. So that's going to take a while. Okay, so we turn that on, that's what we have. Okay, and then we can just, then we can just do a file cache, and I'll be back once that's done. Okay, so this is the cache of my cookie. This is a lower resolution cache that I did, which I can use for simulations. And I've just added a node here as well to show that this is what I want to use for my liquid or NPM. And I can just go out. So let's make the NPM sim. This was pretty easy to do based on the documentation. It was not difficult at all. I would say that I generally would use probably vellum grains or flip fluid for this, but NPM had just come out, so I wanted to try it out for a simulation and just see how it would work. And I'll say that it works pretty well. It's pretty fast, and the setup is really easy. So try it out. I can't wait to use it for more complicated simulations, but it works pretty well. So we want to bring our out NPM, which is in the cookie. So this is the fluid we're using for the chocolate. And we'd also want to bring in the other parts of the cookie for the simulation. So let's do that first. Let's make a geometry container and let's call this right. So for this one, let's bring in the cookie for animation, which is our lower res sim. Let's bring out the one for the sim and let's bring the one for the animation as well. So this is the high res and the low res. So we're doing the same procedure. For this one, let's just make an assemble node. And what we want to do is to create pack primitives again. Let's do a blast. And we want the other one because this is the right. And then let's unpack it. Okay. And let's add a rest position as well, which is something that is very important. I'll talk about it during rendering. And let's add a null. Outright sim. And we can do the same thing here. And this is just alright. Alright. Let's do the same thing for the left. So this will be this. This will be this. And let's call this out left sim. Not left, like that. Alright, so the important thing is to animate, and we want to animate at this object level where we're at. So let's set some keyframes for our animation. Okay, so if we go to frame 48, which is really where things start pulling apart, and let me set my frames per second to 48. And so let's go to 48. Just check that. Yep. Okay. So what we want to do here is set keyframes for that. And let's say around like frame 121 is where I want everything to stop moving. I can move this just towards the side like that. And we can set a keyframe there. And then for the left, we want to set a keyframe for minus 0.1. Yep. And at 48, we want it to be 0. So if we just watch that, so it pulls apart nicely. Okay. So we have those. And now we can go back to our npm sim. Okay. Let's make another object merge and let's take from the left out left sim, and then from the right out right sim. let's do a merge between the two. Okay. And here's where we can make some changes. So I just want to see if this will fit in to the hole that we have. We can scale this a bit more. And maybe let's scale that down. And this one, we use these figures. These are values that I've tested beforehand. So yep. So now it fits perfectly into the hole. And now we can do the NPM solver. So the very first thing is to add an NPM source. For that, for the collider, we need something called NPM collider. And for all of them, we need something called an NPM container. You can see it's already erroring out, telling you the NPM container is invalid or missing. And we just need to drag that over here. And same thing here. Alright, now for this collider, we should set it up better than what we have right now. It's an animated rigid collider. It will use the impute animation, and it just creates VDB that's going to be used to collide with your geometry. On the NPM container, there isn't much to do apart from affect the particle separation, because that affects what you see in your NPM source and in the collider as well. So if we switch this down to 0.01, you can see we have a lot more detail on the collider and also on the source. Alright, and for the source, on the NPM collider, I changed this to all closed. That's different. And then on the NPM source, we can make some changes as well. So what type of material we want is not snow. It gives you all this really nice preset. So I want water, and I want the behavior to be viscous. I change some of these values, like make it more stiff. I change my volume preservation to 0.1, and the viscosity, how I want it to behave, 0.16. I want it to be viscous, but not to the point that it is misbehaving. I think I just used the setup for this really, and then I changed things as I felt were necessary. I did add an age attribute, although I didn't use it, and that's really it for the NPM source. So you can play around with some of these behaviors, how you want them to be. Like if I change this to elastic, that's how it looks, and if I change it to viscous, that's how it looks now. So the only other thing I did was create an attribute adjust float, which I used to affect the viscosity attribute, which now exists in the NPM source. And that's because I didn't want it to have a similar viscosity all around. So for the attribute I want, that's viscosity, adjustment value, I want to be some noise. So let's visualize that viscosity. I like this new visualization we have. So this is how everything looks, and this is after adding some noise. So I can affect this if I want. I can switch it like this. Yeah, make it look a bit different to what we normally have. I can change the min and max, because what this means is this part is going to be very high in viscosity, and these areas are going to be lower. So you can adjust it however you like. If I move this, you can see it still has like a bit of noise, but it's in the area that I want. So that's just how you can affect the viscosity in NPM. And then place that into your NPM solver. Okay. And for this one, I don't have to do too much on this. So let's do a short cache to see what we get. One small thing I forgot to mention, which is why my cache didn't work, is we need to change this into this object. Otherwise, it doesn't move. So this is still into specified object, and you see it doesn't move. So change that into this object, and you can get the movement from the object level. So let's cache it once more. All right, after a short cache, this is what we have. I think that looks really nice. Okay, so how are we meshing this? Very simple. We're going to use a VDB from particles. And we want to set the voxel size to something really low. And we're also going to change this minimum radius. And that's what will make everything pop up. The next thing we should do is a VDB smooth SDF. And that just smooths everything out. And then let's do a convert VDB. Okay, so this is what we have. Which I think looks really nice. I like the way it sort of falls. It's not like running water exactly, but I like the viscosity that I get. And after that, we can just cache this and we can jump into LOPs. So I'll just explain what I did before I jumped into LOPs. I brought everything together. I did a sort of composition. I added a backdrop. I added some cookie crumbles on the side of the cookie, and I did my camera movement as well. And that's really it. So I'm just going to go over some things I did in LOPNET because I used Copernicus for some of the shading. Okay, so this is everything in my LOPNET. I've brought in my cookie specially, and I've imported everything else in the scene. And I have my material library, I have my lights. This spotlight is what is creating this sort of nice light that illuminates just where the cookie is, and I accomplished that by changing the values on the barn doors. I've brought in my camera, and I have my render settings there. So I'm just going to go over how I did the materials, for instance, for this nice sort of teacup or like a tea mug that I did, and maybe also the one I did for the table. These aren't very detailed material tutorials. I'm just showing a simple setup. That's it. So I'm going to reduce this by a lot, just so I can have quick iterations on things. And I might take the cookie out and just remove that because it gets really, it takes a while. Okay. I think this first one is the napkin cloth. And here what I've done is I made a checkerboard pattern, just this, And this checkerboard pattern is, the signature is mono. So to color it, I have to do mono to RGB. And that's what I've done here. And I just put that in a null, which is what I'm going to call in the material library. And in order to add some bumps to my napkin, I wanted to create something that was going to give the appearance of holes. So I made the checkerboard pattern. I increased the rows and the columns. If you're doing just that single line, then you don't need columns or you don't need rows. You just pick one. But for this one, I use this number of rows. And then I've done an SDF to mono, which looking back, I don't think was necessary. I was just trying stuff out. And then I've done a remap. And the reason is because I don't want that pattern to be as dark as it was. So I'm remapping the values. And then I'm putting it into a null, which I called height. And then I've placed a height to normal because I decided against using just the height geometry, using the height in my render. And now I've put a null named normal. So to call this in, I would go into my material library and pick the napkin, for instance. And the great thing about this is you can see it as you're doing it in the viewport. And so what I've done is to bring in an image, and it will work if you put this OP colon slash, and then you can type out where you want that to be. So I'll just do that. So from here, I can say object. I have a geometry container called LOPNET 1. And in this, I have COPNET 1. And I want to bring in my base color. And that's it. Same thing. And for this one, I've brought in my normal. Just plug that using the normal MTLX normal map, and that's going to work. So another one I've done is the jug that I have, and for this one, what I've done is I've made a fractal noise with a whirly pattern, and then I'm plugging that into a distort. To drive the distort direction, I have a fractal noise, and I plug that into the distort. Then I plug this mono into mono to RGB, and I give it a variety of colors. So it's very easy to just iterate and add colors as you wish. And don't forget to plug it out into the null. To make the roughness, I've done a remap as well, just determining how shiny or rough I want it to be, and plug that into another null named roughness. You can visualize it here. I'm just looking at this, but sometimes it crashes, so I'm not always looking there. And finally, for the table, so what I've done is I have a checkerboard pattern where I'm using only the columns, and I have a fractal noise that looks more like would look like to me, and I'm blending these two just a bit. So the blend is basically like a mix node, and you can mix it however you see fit. And then I'm doing the distort again with this sort of fractal noise, so it's not all straight. I'm doing a mono to RGB and into my null. And of course, don't forget, same thing for roughness, do a remap and put that into a null called roughness. And for this, I'm also doing the same thing for the normal. I plug that into a remap. I put it first into a height null, which eventually I decided against. I switched that from height to normal. and plug that into a normal node, and you can visualize it here as well. So that's how I've done the Copernicus. And if I just plug the cookie back, just one thing I want to talk about here. Bring back my cookie and bring back my crumble. Okay, so for the cookie, if I go in here, I've created a very straightforward setup to drive some displacement and also affect more of the specular as well. And what I've done is use this noise called Fractal 3D. I have an MTLX multiply, which calculates the frequency for the noise, and also an add, which is supposed to be used for offset. And normally you would plug in the MTLX position, but I already have a position that I want to use, which is my rest attribute. And that's what I'm supposed to plug in to this instead of the position. And the reason is because if you don't plug that, then the noise seems to dance on the surface of the geometry instead of being static. And that's because the geometry itself is moving in world space. So you wanted to maintain that rest position that we originally created, bring that into LOPNET, and then use that to drive your noise instead of a regular position. And that's basically it. For my light setup, like I mentioned, just a spotlight, and I did add a small area light here to ensure that everything here is not completely dark. If I do a short render, I hope it works. Okay, so that's how it looks like now. And if I just take away this area light, you can see everything here is much darker. So I'm just adding a little bit of light, but not too much to overpower the spotlight. And that's basically it. So that's the end of the tutorial. I've included the project file in the description. I'd like to do some more tabletop tutorials and small scale simulations. Let me know what you think in the comments.